Okay, we're going to look at how to do some of these word problems. So if you've got where you have two things working together, and you have to find one or the other, or maybe the two combined, they're going to give you some information. So we have to think about rates. How fast can one person do one job? How fast can another person do that same job? And then together, that same job, how fast they can do it. So we're going to add the two together, but it's all going to be rates. So it says here, working individually, Paige and Malia can each work the landscape job in the time shown. So Malia can do it in 4 hours, and Paige can do it in 6 hours, right? So those things are going to be our rates, because we can do one job in 4 hours. And like miles per hour, we have jobs per hour, okay? And Paige can do the job in 6 hours. Then together, how fast can they do the job? We don't know, so we let that be X. One job in X hours, okay? So now all we got to do is multiply by a common denominator, and that looks like 6 and 4 both go into 12. I could take them times each other, 24x, but it's easier to work with 12 here. So if I take everything here times 12x, the 12 and the 4 will reduce to 3, so I got a 3x, right? Because 12x over 4 is going to be 3x, right? And then this one, 6 goes into 12 twice, so that's going to be a 2x. And then on the last one, the x's are going to cancel, so it's going to be 12. So we got 5x equals 12, divided by 5. X is going to be 2 with 2 left over. So that's about 2.4 hours. They can do the job together in about not quite 2.5 hours. Okay? That's just a basic, you're looking at rates. How fast can each person do a job, jobs per hours, and then together, jobs per hours again. So this is 20 here is almost the same thing, except now it's slightly different because they don't give you a time. Okay, so some problems are going to give you a time, and so you're just going to put a 4 and a 6 or whatever the time they give you is. But now, if they say somebody works faster than somebody else, they don't give you an actual time, then you have to think about the number of jobs they can do in the time it takes the other person to do their one job. So that's what they're talking about here. Russell and Aaron working together can build their shed in 8 hours. So that's going to be 1 over 8, because together they can do one job in 8 hours. And then it says, all right, Aaron works 3 times as fast as Russell. And then it asks, how long does it take Russell to build the shed? So Russell, we don't know how long, so he can do the one job in X hours. But just like that pipe question we did the other day, how many jobs could Aaron do by himself in the time it takes Russell to do it once? He's 3 times as fast, so he could do 3 jobs in X hours. So now we're going to multiply by our common denominator again, which is 8x. And so that's going to, here the x's are going to cancel, right? So it gives me 8. And then again, the x's are going to cancel there. So that's going to give me 24. And then here the 8's cancel. So that's going to give me x. So x is 32 hours. So in other words, it takes Russell 32 hours to do the job by himself. Okay? And so, that time we had to change the top number. Okay? We had to think about, all right, how many jobs could one guy do in the time it takes the other guy to do one job? Okay? That's one type of story problem.